So in this very lesson, we want to look at solving a quadratic equation using the completing of squares. The question is when and how do we use the completing of squares to solve a quadratic equation? To get answer to this question, let's look at this particular example. So we want to solve this quadratic equation using the factorization approach. So with the factorization approach, the first thing that we normally do is to multiply the coefficient of s squared by what? The constant. So we are going to have 1 multiplied by 3. That gives us what? 3. Now once we find this 3, we find the factor pair of these 3. It means we are going to look for two numbers that when we multiply, we are going to get what? 3. In these factor pairs, we have 1 times 3 will give us 3. And then we have minus 1 times minus 3. So once we have these factor pairs, we look through to see which one of them, when we add together, will give us the coefficient of what? X, which is what? 5. So let's look through and see. 1 plus 3 will give us 4, and it is not equal to 5, so we can't use this. Now let's look at this. Minus 1 minus 3 will give us negative 4, and it is not equal to 5. In that case, we can't proceed to use the factorization approach. When this happens, then we have to go in for more stronger method to help us solve this quadratic equation. And this calls for the completing of squares. So how do we use it? Let's look at it. So we want to solve this quadratic equation using the completing of squares. So in doing that, the first thing that we are going to do is to transpose the constant to the right hand side of the equal sign. So we are going to have now once you have this, then you make sure that the coefficient of s squared is 1. So looking at this, the coefficient of s squared is 1. So we are not going to touch it. Then we move on to the coefficient of what? X. The coefficient of x is what? 5. So in completing the squares, we are going to multiply the coefficient of x by half and then we square it. So we have 5 multiplied by half and then we square it. This is going to give us 5 all over 2 all squared. Now once we get this, we are going to add this to both sides of the equal sign. So we are going to have, so we are going to add this, so plus 5 over 2 all squared is equal to minus 3 plus, we are going to add this to the right hand side all squared. Now once we have this, we do some small simplification. Now we have s squared here, we can group it, so we have s squared plus 5 all over 2 all squared is equal to minus 3. Now when we simplify this, we are going to get 25 all over 4. Now since we have s squared here, we can write this as x plus 5 all over 2 all squared is equal to minus 3 plus 25 all over 4. So when you simplify this, we are going to have x plus 5 all over 2 all squared is equal to what? 13 all over 4. That is when you simplify this. Now we are looking for x, so what do? We have to take the square root on both sides of the equation. So from here we can see that these two will cancel what? The radical sign. We are left with x plus 5 all over 2 is equal to plus or minus root of what? 13 all over 4. Now we are looking for x, so we can transpose this 5 over 2 to the right hand side. So we'll be left with x is equal to minus 5 all over 2 plus or minus, when we simplify this, we are going to get with 13 all over what? So from here, we can see that our x, let's call this one x1, is equal to minus 5 over 2 plus, we are using the positive one first, with 13 all over 2. And then our x2 is equal to, using the minus, we have minus 5 all over 2 minus with 13 all over 2. Now when we simplify, we can see that our x1 is equal to minus 5 plus with 13 all over 2. And from here, you can see that our x2 is equal to minus 5 minus with 13 all over what? 2. So the value for x which satisfies this quadratic equation is either s is equal to this or s is equal to that. Let's look at one more example. So we want to solve this quadratic equation using the completing of squares. And as I said earlier on, the first thing that you have to do is to transpose the negative 2 to the right hand side of the equal sign. So we are going to have is equal to what? Positive 2. Now once we are done with this, then we move on to the coefficient of s squared. We have to make sure that the coefficient of s squared is 1. If it is not 1, then we have to make sure it is 1. So from here, to make it 1, then we are going to divide through by what? 5. So we are going to divide through by 5, divide through by 5, divide through by 5, so that this will cancel this. At the end, you will be left with x squared minus 6 all over 5x is equal to what? 2 all over 5. Now once the coefficient of x squared is 1, you move on to the coefficient of x. So to complete the squares, we are going to multiply the coefficient of x by half and then we square it. So we have negative 6 all over 5 multiplied by half, and then what do? We square it. So we are going to get 6 all over what? 10 all squared. Now we can simplify this more. We can have 2 into 6, we have 3 all over 5, and all of this is squared. So once we have this minus 3 all over 5 squared, we are going to add this to both sides of the equation. So we are going to have x squared minus 6 all over 5x. Then we add this, so we have plus minus 3 all over 5 all squared is equal to 2 over 5 plus, we add this, minus 3 all over 5 all squared. So let's group this x squared and then this squared together. So you have x squared plus minus 3 all over 5 all squared is equal to, now this is going to give us 9 all over what? 25. Now these two, we can write it as x minus 3 all over 5 all of this squared is equal to, now when you simplify this, you are going to get what? 19 all over 25. So from here, to do away with the square, we take the square root on both sides of the equation. So you can see that this square will cancel the radical sign here. You will be left with x minus 3 all over 5 is equal to plus or minus square root of 19 all over what? 25. So we want to look for the value for x. So let's transpose the whole of this to the right hand side of the equation. So we are going to have our x is equal to 3 over 5 plus or minus square root of what? 19 all over 25. Now from here, we can see that our x is equal to 3 all over 5 plus or minus, when we simplify this, we are going to get root of 19 all over what? 5. Since we are having plus or minus, we can split it into 2 to have our first x1 is equal to 3 all over 5 plus root of 19 all over what? 5. And we can write this as x1 is equal to 3 plus root 19 all over what? 5. Now let's look at the negative aspect. So we have our x2 is equal to 3 all over 5 minus root of 19 all over what? 5. Now we can write this as x2 is equal to 3 minus root of 19 all over what? 5. So the value for x which satisfy this quadratic equation is either s is equal to this or s is equal to that. Let's look at one more example and then we run out of here. So we want to solve this quadratic equation using the completing of what? Squares. So the first thing to do is to carry the whole of this -1 to the right hand side of the equal sign, and you'll be left with this will give us +1. Now once we are done with this, we move on to the coefficient of s squared. We have to make sure that it is 1. So if it is not 1, then we have to divide through by the coefficient of that s squared. So we are going to divide through by 2, by 2, by 2. So that this will cancel this, we have what? S squared. Now once we are done with the coefficient of s squared, we move on to the coefficient of what? X. So to complete the squares, we are going to multiply the coefficient of x by half, we square it. So we have -3 all over 2, we multiply it by half, and then what do? We square it. He is giving us -3 all over what? 4. And then we square it. So we are going to add this to the left hand side, this to the right hand side. So we will be having s squared -3 all over 2x plus this. And then we have 1 all over 2 plus this. Now once we reach this well point, let's group the s squared and then this squared together. So we have s squared plus -3 all over 4 all squared is equal to 1 over 2, and then this will give us 9 all over what? 16. Now with this squared and then this squared, we can write it as x -3 all over 4 and all of this what? Squared. Now when you simplify this using your calculator, you are going to get 17 all over what? 16. Now we want to do away with this squared. So what do? We have to take the square root on both sides of the equation. So we have this, and the moment you take the square root, we are going to have plus or minus this. Now once you have this, we can see that this squared will cancel the radical sign. We are left with x -3 all over 4 is equal to plus or minus root of 17 all over this will give us what? 4. So we want to find the value for x, so we have to carry the whole of this to the right hand side of the equation. So we are going to have x is equal to +3 all over 4, then we have plus or minus root of 17 all over what? 4. Since we have plus or minus, we can split it into 2. So we have our x1 is equal to 3 all over 4 plus root of 17 all over 4. And this is the same as 3 plus root of 17 all over what? 4. Then we can have our x2 to be 3 over 4. Then we have minus root of 17 all over 4, which is the same as x2 is equal to 3 minus root of 17 all over 4. So the value for x to satisfy this quadratic equation is either x is equal to this or x is equal to. That's as easy as that. This brings us to the end of today's lesson. See you tomorrow. Bye bye.